Now that we've narrowed down our search for the possible rational roots, we can go ahead and solve our polynomial equation. And so the most efficient way to solve this polynomial equation by hand is to use synthetic division. And so let's go ahead and test out the three possible roots that we found. I'll start with 2. So if we start with 2, we're going to synthetically divide that into our polynomial. So we'll get 1, 2, -2, -4, 5, 10, and -26. This shows us that 2 is definitely not one of our rational roots, and it also confirms that our roots have to be bigger than 2 because we see a sign change, another sign change, and another sign change. Remember, when the sign changes alternate, this shows us a lower bound. Let's go ahead and try 4. So we have 1, -4, 9, -36. And if we do synthetic division, we're going to get +4 here, 0 here by adding. We multiply 4 times 0, we get 0. We get 9 here. 4 times 9 is +36. And we get 0 here. Remember, when our remainder is 0, this confirms that 4 is a real root. And so our roots, we have just confirmed that x equals 1. If we inspect our degree here, we should see that we have a possible total of 3. Well, we definitely have 3 roots. But 3 of them could be positive, or 1 of them could be positive, and 2 could be imaginary. And so since we've just confirmed that one of our roots is positive, and we only have one more root to test here, 3, we know that 3 cannot be a root, because if we have one positive root, that means we have to have 2 imaginary or complex roots. And we can confirm that by looking at our factored form of our polynomial. So if I take the f of x, I can see from here that we would have x squared plus 0x plus 9 left over as our result of our synthetic division. And the fact that we have a root of 4 shows us that we could have a factor of x minus 4 as our second factor. And so right here, we have just written the factored form of our polynomial. If we go ahead and solve, we see that, well, of course, we confirm our root of 4. And here we get an equation, x squared plus 9 equals 0, where we can solve by getting x squared by itself and taking the square root of both sides. Now pay close attention here. We're taking the square root of a -9, and so it's just like taking the square root of a +9, except we're going to get a positive, negative, or -3i, because the square root of negative numbers always results in an imaginary number. And so we have finally solved our polynomial equation and found that we have 3 roots. A root of 4, which is a real positive number, and 2 imaginary solutions or complex solutions, 3i and -3i. Watch the chapter 3.3 checkout video to see more worked examples that run through the entire process, starting with our polynomial function and resulting in our roots.